Hi, this is Hyun Kook Lee from the APL. I'm here to quickly demonstrate impulse response measurement tool within HAART, Huddersfield Acoustical Analysis Research Toolbox, which you can freely download from the link below. So firstly, we need to set a new project. So click that and designate your folder where all your impulse responses will be saved. And it will automatically generate a JSON file for your configuration, which you can recall by opening existing project here. And file naming convention by default is IR-input number and output number. So basically your microphone number and output speaker number and the take number. So if you look at the excitation menu, basically we have three available methods you can choose. Exponential sine sweep method, which is probably the most popular method these days, and pink noise or MLS, maximum length sequence method as well. We'll be demonstrating this sweep method. IR length is the length of the actual impulse response that will be generated. So it should be determined by the reverb time of your space. So if you know a rough reverb time of your space, let's say it's about 2 seconds, then it needs to be long enough to cover the whole reverb decay. So in this case, I'll just set it to 1. Amplitude is the output level from your speaker. So it's always best to start from a lower level, so -25 or so, just to be safe. And excitation parameters. This is the length of your sweep signal. So the longer, the better in theory, because there will be a better chance to remove nonlinear distortions, even if some noise occurs during measurement, if the sweep is long enough. So usually 10 to 15 seconds sweep length is used for critical measurement in a concert hall or any room environment. But if your environment is super quiet and there's no any noise occurring during the measurement, short length, like 1 to 5 seconds, is still acceptable. So I'll just set it to 1 second for now. Frequency range, it should be dependent on your speaker's frequency range. And phase, yeah, we can just leave it there. This is the phase in and out times for your impulse responses. So it should be very quick. And this input monitor, select channel. So this is my microphone's frequency response right now, real-time presentation of the frequency response of the first microphone, and then you can change the microphone number here. Monosum will basically sum all of the microphone signals responses. And I have only one microphone here, but you can also set up to 24 microphones and up to 24 loudspeakers. So basically, the sweep will, each speaker will play the sine sweep one by one in series. If you have 24, then you will hear 24 sweeps one by one, and all of the microphones will capture that sweep in a room. And the HAART, this software package, automatically processes the sweeps captured in the room and deconvolve it to obtain the meaningful impulse response. So if you understand the nature of the exponential sine sweep method, basically it involves the original sweep and the recording of the sweep in the room, and then you have to convolve it with inverse sweep, which is called deconvolution process. And there is also some necessary equalization process involved at the end. So they're all done within this all-in-one toolbox. So we'll just set it to 1 input and 2 outputs. And if you go to options, this is an important thing to check, because the input device and output device you need to select them correctly, and the sample rate, vector sizes, and so on. So at the moment, I'm using merging Ravenna Anubis interface for input, but the output device, I just set it to internal drive just to record it on OBS. So you'll be hearing the sweep internally routed to OBS. But the output, if you go into the input-output mapping menu, sometimes, well, by default, it needs to be one-to-one map. So the input channel 1 needs to be mapped to the first input to the interface. And output channel 1 to 16, they also need to go out to loudspeakers 1 to 16. At the moment, I don't have any more than 2 outputs in this internal driver, so it's limited to only 2 outputs. Okay, so now let's play this sweep and see what it sounds like. Okay, that's all done. Now we can see these 2 files generated in the folder you created. So we have IR1-1, which is the first microphone from the first speaker, and the same microphone capturing sound coming from the second speaker. Okay, so now let's have a look at an impulse response we captured. This is actually a response I already captured previously in my home office. And as you can see here, this is a tiny signal. It's because my microphone preamp gain was not high enough, and also we're using 32-bit audio, so the SNR, signal to noise ratio, is still pretty large. So we can see this impulse when we normalize the signal. We can see this impulse followed by the reflections. And you can quickly see the frequency response. Okay, so that's pretty much about it. When you download HAART package, it includes user guide manual, so please have a look at that. And yeah, I'm sure you'll find it useful, especially when you're doing multi-channel impulse response measurement. Okay, thank you very much.